Good day, everyone. I'm back. I'm Alvin Alvarez at your service. And now let's teach you how to solve the exercise number 11 at page 55 of Engineering Advanced in Mathematics of Wiley 5th edition. Okay, and stated here that in 11, work example 2. So example 2 in the book. If the tank is a sphere initially filled with water, instead of just a hemisphere, how long will it take for half the water to run out? How long will it take for the tank to drain? Assume that there is a small hole at the top of the sphere where air can never enter the tank. Okay, in example number 2, the diagram shows that it looks like this. It's just an hemisphere, but the same as is also in a sphere. Let's assume that as the volume of sphere is equivalent to 5x squared dy, and the volume of the cylindrical is 5r squared dl. So 5r squared dl equivalent to v dt, volume times the time, derivative of time. So why would you get the v? Potential energy is equivalent to kinetic energy. Potential energy is equivalent to mgh is equal to 1/2 mv squared. So v is equal to 2gh, but in our diagram we use it as a y, so square root of 2gy. V is equivalent to 2gy. This is it, 2gy. Now equate this to this, because the volume of sphere is equivalent to something like this in a small portion. So pi x squared dy is equal to pi r squared square root of 2gy. dt. Okay. But in this equation we have a problem. X. But our dependent variable is y and t. How to get the x? So recalling the radius, x squared plus y squared equal to r squared. So this is one. We use this. So x here, x squared here is equivalent to r squared minus y squared minus 2yr plus r squared. So simplifying that equation, x squared is equal to the negative y squared plus 2yr. This is r, this is radius. This is our r. So substituting this equation in here, so but first of all we must cancel pi because it's just redundant and it's just a constant. So negative y squared plus 2yr dy in terms of y is equivalent to r squared square root of 2g square root of y dt. So bring to the other side of y. So after and integrate. Bring this y in here. So after integrating, we get the negative 2. After integrating, we get the negative 2 y 5 over 2 over 5 plus y to the cube over 2 r over 3. 2 times 3 is 4, so 4 is equal. I almost forgot that the volume of the cylindrical is negative because it going back down. So it was negative r squared, the square root of 2g t, because it was integral, and then plus c. This is now our general solution, and let's find c. So at c is equivalent to r, t is equal to 0. So equating this to this, we get, I know it was y. We get c, not c substituting the r, of course that. So y is equivalent to r because it was our radius. So negative 2 to the square root of r to the 5th plus 4 r to the 3 halves plus r over 3. This is over 3 and this is over 5. This equals to the constant c. It becomes 0 because t is 0, so it's equal to z. So r to the 5 over 2 plus r 5 over 2, we must get their LCD. So LCD in here is 15. So over 15. So 15 divided by 5 is 3. Negative 2 times 3 is negative 6. Negative 6 r to the 5 over 2. Last. 15 divided by 3 is 5. 5 times 5. 5 times 4 is 20. So it's equivalent to 20. 15 divided by 3 is 5. 3 is 5 times 4 is 20. So 20 r to the 3 halves is equals to C times R. R, 3 halves plus R is 5, so it becomes 5 over 2. 3 halves plus 1 is 5 over 2, so 5 over 2. So negative 6 plus 20 is 14. So constant is C is equal to the 14 C R to the 5 halves over 15. It's 15. It's 15. Because y is 0, followed each other. So substituting that into our equation, and in our equation it must be look like this. 4 over r 4/3 r y the 3 halves minus 2 over 5 y to the 5 halves is equal to negative r squared square root of 2gt plus 14 over 15 square root of 2 r to the 5 halves. That's it. That is our particular solution. But our problem says that we must find how long will it take to have water to run out. So how long? So if C, how long will it take for half the water. So C is equivalent, no, Y is equivalent to R over 2, 1 half. So Y is equivalent to R over 2. And at T, what is T? After substituting, we get that T is equals to 14 square root of 2 minus 14 over 15 r squared square root of 2g. It's just a simple arithmetic, substituting the y2 in our particular solution, and we get the time t because it's just only one unknown. So that is t is equivalent to 4 square root of 2 minus 14, 15 r squared 2g. So another question is that how long will it take for the tank to drain? So our y equivalent to 0. Y equivalent to 0. And what is our t? T here is equal to 14 over 15 square root of g r squared r to the 5 over t. Five halves. Okay. Substituting y, it cancel out, it becomes cancelled, and this is just t, so r. This is that. This is now the answer, so I hope that you understand my explanations, and thank you.